Okay, we have learned how to do the inverse Laplace using the 7 basics formula and linearity property and the first shift property. Now we are going to learn how to do the inverse Laplace transform using partial fractions. Partial fractions is the first case is a linear factor. Example, okay. We want to do the inverse Laplace of 3s plus 1 over s squared minus s minus 6. Now the s squared minus s minus 6 can be factored as two linear factors s plus 2 times s minus 3. Here, if you break it using linearity property also, so you break it using linearity property, okay, there is no formula how you do it. Gets the inverse Laplace of 3s over s plus 2 over s minus 3. That's why you have to decompose this fraction into two fractions by using the partial fractions. Okay, so to do the partial fractions with two linear factor, okay, where the denominator you have the first linear term s plus 2. So we break it become a over s plus 2. Notice that if our denominator here, this is a linear term mean s power 1, numerator will be always 1 degree lesser than your denominator. That's why which is s power 0 or only constant term. That's why you have a over s plus 2. Okay, for the second linear term, then we have a plus b over s minus 3. So our task is actually to obtain what is the a and b. Means from initial this fraction, we break it into two fractions where we easily can do the inverse Laplace transform. Okay. Later on, by doing the cross multiplications, so a times s minus 3 in the numerator, then plus b times s plus 2 for the numerator, and denominator you multiply both linear terms become s plus 2 multiply s minus 3. So you notice that left side, right side have the same denominator, and you can cancel out, compare the numerator for both hand side. Hence 3s plus 1 will be equal to a times s minus 3 plus b times s plus 2 here. In next time, you can just from here 3s plus 1 over s plus 2 s minus 3, break it two linear term. Then we have the first linear term is s plus 2. They become a over s plus 2. The second is b over s minus 3. And then we can skip this step by just comparing the numerator. You have 3s plus 1. A term, you multiply with s minus 3, b with s plus 2. Then we compare left hand side and right hand side. Notice that for linear term s minus 3, for easy calculation, you can let s equal to 3. Because when you let s equal to 3, first step you let s equal to 3, then 3 minus 3, this term will be 0. And then for the b term, you have 3 plus 2. 3 plus 2, you get 5b. And left side, 3 times 3, 9 plus 1, you have 10. Then 10 equal to 5b, you can easily find that b is actually equal to 2. We have another linear term. This first. For another linear term here, s plus 2, to make the linear term become 0, then you plug in s equal to negative 2. Negative 2 here. So negative 2 plus 2, the b term 0, then you can find for the a term. So negative 2 minus 3, so you have minus 5a. Left side 3 times negative 2, negative 6 plus 1, so you get negative 5. Hence a will be equal to 1. So plug in, this is the a value 1 over s plus 2, b is 2 over s minus 3. Hence, to find the inverse Laplace of 3s plus 1 over s squared minus s minus 6 will be equal to the inverse Laplace of 1 over s plus 2 plus the inverse Laplace of 2 over s minus 3. Okay, easily from you can find that the inverse Laplace of 1 over s plus 2 is actually exponent negative 2t. And the inverse Laplace of 2 over s minus 3 will be 2 times exponent 3t. Look at one more example for the linear term. 9s minus 8 over s squared minus 2s. Okay, we factor out s. So we have the first linear term, which is s. Okay, second linear term is s minus 2. So we break it become a over s. So we have s term, and second term plus b over s minus 2. And then we compare the numerator at both hand sides. So you have 9s minus 8 equal to here a times s minus 2, okay, plus b times s, because the denominator will be cancelled out. Now, for the linear term s minus 2, you substitute s by 2, so that this term 2 minus 2 will be 0. Then s is 2, so you get the right side will be 2b. Substitute s by 2, 9 times 2, 18 minus 8, we got 10. Hence, you can easily get the b is equal to 5. Then you plug in b here 5. Okay, for linear term s, then you substitute s equal to 0. Okay, for that, I erase it first. That's easy to see. Okay, so for the linear term here, s, you substitute s equal to 0. So the b term will be cancelled. So s equal to 0, then the right side you have negative 2a. So s equal to 0, then we have left side is negative 8, hence a equal to 4. So you plug in a equal to 4 here, and then b equal to 5. Then you can decompose 9s minus 8 over s minus 2 equal to 4 over s plus 5 over s minus 2. Hence, the inverse Laplace transform of 9s minus 8 will be 9s minus 8 over s minus 2 will be equal to the inverse Laplace transform of 4 over s plus inverse Laplace transform of 5 over s minus 2. The inverse Laplace of 4 over s will get 4. Inverse Laplace of 5 over s minus 2 will get 5 times of exponent through t. Now we look at a repeated linear factor. For example, we have the s squared minus 15s plus 41 over s plus 2. Okay. Linear because s plus 2, this is power 1. Okay, and here s minus 3 linear term but repeat 2 times. Okay, to do the partial fractions, so you have a over s plus 2. Okay, the second linear term is s minus 3, so plus b over s minus 3. For repeated linear term, then you have c over s minus 3 power 2, because they repeat until 2 times. So s minus 3 power 2. If this is 3, then you have d over s minus 3 power 3. Okay. And then for the right side, to make the same denominator, so the right side you must have s plus 2 times s minus 3 squared. Okay. And then so a here you already have the term s plus 2. You have this term s plus 2, you left out s minus 3 squared. That's why a you multiply with s minus 3 squared. So that when you cancel out, it's actually you get back a over s plus 2. Okay. And then for the b term, notice that you have s minus 3. Okay. b over s minus 3. Okay. Before that, maybe I have to erase back so that easy for you to view. Okay. Notice that b, you have s minus 3. You have power 1. So you left s minus 3 one more time, so that you can get s minus 3 squared. And then b in you don't have the s plus 2, that's why b you have to multiply by s plus 2. Okay, so that when you simplify the b term, you will notice that s plus 2 you cancel. Okay, this one you cancel one time, so that's why b become b over s minus 3. Okay, and for the c, c, you notice that I erase first. C. Okay, you want to get s minus 3 squared for the denominator. So we have s minus 3 squared. And then c, you left the s plus 2. Left s plus 2. That's why c you multiply with s plus 2. That's why when you cancel, so c over s minus 3 squared. Or in conclusions, to compare the numerator, this is the left side equal to the right side. Okay, first of all, this one you break, become a over s plus 2, b over s minus 3 plus c over s minus 3 squared. Okay, a term, a, you have s plus 2, hence you left s minus 3 squared. That's why a need to be multiplied by s minus 3 squared plus, b. B you have the s minus 3 power 1 already. Okay, so you still need one more time s minus 3 power 1. Okay, and b you don't have the term s plus 2, that's why b you multiply by s plus 2. Okay, for the c term, you already have the here s minus 3 power 2, you left out s plus 2, that's why c multiply with s plus 2. Okay, I repeat one more time. Okay, a, you have s plus 2, so you need to multiply by this one. So a s minus 3 squared. Okay, for b, you have here s minus 3 power 1, already power 1, left one more term. And then b, you don't have this one, that's why you need to multiply by s plus 2. c, we have here, you need to multiply by s plus 2. Okay, after that, notice, for the first linear term s minus 3, we'll let s equal to 3. S equal to 3. So 3 minus 3, this term, a term gone. The b term also gone because 3 minus 3 is 0. 0 times anything, you got 0. That's why the right side, you have here 3 plus 2, which is 5. So you have 5c. Okay, and here, and then you substitute, your s equal to 3 into your left side. So 3 squared, you have 9. Okay, substitute 3 into here, negative 15 times 3. So you have 9 minus 45 plus 41. So you get 5. 5, yeah? Okay, after that, for do it up first. Okay, after that, for the second linear term s plus 2, we let s equal to negative 2. S equal to negative 2. Okay, so the b term will be negative 2 plus 2, we get 0. So b term gone. We plug in s equal to negative 2 into the a term. So negative 2 minus 3. We have negative 5 squared it, we have 25a. 25a at the right side. Okay, again, so plug in s equal to negative 2 into the left side. So negative 2, you square it, you have 4. Okay, so minus 15 times negative 2, total is plus 30. And then you plus 41. So you get the answer is 75 at the left hand side. So 75 equal to 25a, hence a will be equal to 3. Okay, so 5 equal to 5c, hence c equal to 1. Okay, now notice that we have only 2 linear terms, but this is repeated. So we have obtained c and a. In order to obtain b, we have no more linear term. Okay, have no more linear term. Okay, so let me clear first. Okay, let me clear first. We got no more linear term. Okay, And then to find, you have only two linear terms, and to already obtain C and A, to find your B, normally will be easier. You use the highest degree term. Mean highest degree term. Left side, the highest degree term in here is S squared. So the coefficient for S, so I put it here S squared. Mean the coefficient for S squared at left side, mean you have 1 S squared. We take the highest degree term because it will be easier to, you don't need to expand everything. Because here, when you A times this is S squared, so we have A S squared, means this one. So A S squared, the coefficient will be A. For the second term, S times S times B, so B S squared, the coefficient will be B. This is linear term, don't have the quadratic term. Hence, the S squared term, left side, the coefficient is 1, right side you have A S squared, which is A, B S squared, which is B. You already obtained A is 3. Hence, B will be 1 minus 3, which is equal to negative 2. So plug in A is 3 over S plus 2. B is negative 2 over S minus 3. C here, 1 over S minus 3 squared. Hence, the inverse Laplace transform of S squared minus 15S plus 41 over S plus 2 over S minus 3 squared will be equal to the inverse Laplace of, using linearity property, will be equal to the inverse Laplace of 3 over S plus 2. And then the second term, minus inverse Laplace of 2 over S minus 3 plus inverse Laplace of 1 over S minus 3 squared. So for the first term, easily, you can find that, factor out 3. So 3 times of inverse Laplace of 1 over S plus 2, you get exponent negative t. So total is 3 exponent negative 2t. For the second term, this one you get 2 minus 2 exponent 3t. The third term here, notice this is in the functions of, in the fs minus 3. Fs minus 3. We call that the fs minus 3. So if we have the inverse Laplace of fs minus a, the result will be exponent at ft. Hence, the result here, you should have the inverse Laplace. This one you find the inverse Laplace of fs minus 3. The result will be, a is 3. Result will be exponent 3t ft. 3t ft. Where the ft is actually inverse Laplace of your fs. So you got this exponent 3t here, inverse Laplace of the fs. Fs is 1 over fs, so become s squared. Inverse Laplace of 1 over s squared, you have t. So total your answer 3 exponent negative 2t minus 2 exponent 3t plus t exponent 3t. And then we have the quadratic factor. Lastly, we have the quadratic factor. 4s squared minus 5s plus 6 over s plus 1, s squared plus 4. Quadratic here. S power 2. So we have a quadratic term. Hence, for linear term, we break it, become a over s plus 1. Quadratic term. As I said, you have s squared plus 4. As I said, numerator must is a polynomial which has a 1 degree lesser than your denominator. If denominator is s squared, then numerator must be polynomial of degree 1. Since you use a, now we have b s plus 1. So this is polynomial degree 1, your denominator polynomial of degree 2. So you notice linear term because this is s power 1. So this is actually you multiply s power 0, which is actually 1. So s squared, this is s1. So you notice that for partial fractions, your numerator is always 1 degree lesser than your denominator. So s squared, so this is s power 1. Okay, so that's okay. Then we compare the numerator, okay, the numerator term, okay, because by doing the cross multiplication, okay, your denominator will be same, and we just compare the numerator at left side and right side. Okay, so the left side 4s squared minus 5s plus 6 equal to right side. Okay, using cross multiplication, you have a times s squared plus 4, okay, plus b. Make sure b here, this is a whole group, so make sure you have a bracket. If you don't have brackets, you only take c multiplied with, okay, the same thing here, s plus 4. So usually you must have a bracket, okay, and here must have a bracket. If not, you only take c multiplied with s plus 1. But in fact, it's a whole group, bs plus c multiplied with s plus 1. Okay, to determine the coefficient of a, b, c, again, okay, for linear term, okay, s plus 1, we'll let s equal to negative 1. So negative 1 plus 1, this term gone. Then negative 1 squared, you have 1, so 1 plus 4. Okay, right side you get 5a, and then here left side, so negative, okay, I'll just show you how to get it. So you have negative 1 squared, okay, is 1 times 4, so 4 times 6, 10, 10 actually 10 plus 5, so 15. Okay, or you want to calculate 4, okay, times negative 1, okay, that's a square, minus 5 times negative 1, okay, plus 6, then you get 15, okay, 15. So 15 equal to 5a, hence a is equal to 3. Okay, because you have only one linear term. Okay. Another easier way to calculate, we will always let s equal to 0. S equal to 0, because 0 easy to do the calculations. Okay, now okay, erase first. Okay, later on we let s equal to 0. Okay, in left side and right side, when let s equal to 0, left side we left 6 here. Okay, we let s 0, so you have 4a. Okay, s 0, this term gone, so you have only c times 1. So okay, so 6 equal to 4a plus c here. You already obtained a is 3. A is 3 here. So, okay, 4 times 3, 12. So, 6 minus 12, you have negative 6. So, c equal to negative 6. Okay, again, we have let s equal to 0. You see, okay, we found c equal to negative 6. From the s equal negative 1, you find, okay, a equal to 3. To find the b, again, we always compare the highest degree term. So, mean if you don't have any more linear term, it's either you let s 0 or you compare the highest degree term. Okay, you don't need to wasting our time to expand everything and collecting the same term and then you compare it. Okay, do that again. I erase first. You can easily see. Okay, now, okay, the highest degree term here is s squared. The coefficient is 4, so 4 here. Okay, compare the s squared term. Left side is 4, right side you have here as squared, where the coefficient is a. Bs, bs multiply s, you have bs squared, so the coefficient is b. Okay, you already obtained a is negative 6. Okay, sorry, that is c. A is actually, a is 3. So b will be 4 minus 3, which is equal to 1. Okay, plug in the a, which is 3. So you have a right side 3 over s plus 1. Plug in b is 1. So s, c is negative 6. So s minus 6 over s squared plus 4. You plug in, this is a, b is 1, c is negative 6. Okay, and for the second term, s minus 6, we break it using, okay, we break it into two fractions, two quotient functions. Hence, okay, the inverse Laplace transform for 4s squared minus 5s plus 6 over s plus 1 times s squared over s squared plus 4. Okay, since they are decomposed, okay, it using the partial fraction, we reach 3 over s plus 1 plus s over s squared plus 4 minus 6 over s squared plus 4. Hence, okay, using the linearity property, this fraction will be equal to the inverse Laplace of this fraction will be equal to the inverse Laplace of 3 over s plus 1 plus inverse Laplace transform of s over s squared plus 4 minus the inverse Laplace transform 6 over s squared plus 4. Okay, so for this first term here, the inverse Laplace of 3 over s plus 1, you get 3 exponent negative t. Okay, second term, you get so we have s, so this is a cos 2t. Okay, for the last term here, 6 is actually, erase first. Okay, the 6 is actually, you can put it as 3 times of inverse Laplace of 2 over s squared plus 4. The inverse Laplace of 2 over s squared plus 4, you get sin 2t. So you totally have minus 3 sin 2t. Okay, so I repeat back how you do the partial fractions. For linear factor, for example, you have s plus 2, s minus 3. You break it, become a over s plus 2 plus b over s minus 3. Okay, by doing cross multiplication, so you have a times s minus 3 plus b times s plus 2. Okay, notice denominator will be same at both hand side. Hence, you just compare the numerator. Okay, to calculate your coefficient a and b easily, if you have the term s minus 3, then you substitute s equal to 3. So the a term gone, you can calculate for your b. Okay, for the linear term s plus 2, you let s equal to negative 2, because negative 2 plus 2, you have 0. Okay, then you can calculate for your a term. Okay, then this fraction it will decompose into two quotient function. Then you can easily do the inverse Laplace transform by using the basic formula of inverse Laplace transform. The third example, for repeated linear factor, then this one you break a over s plus 2, b over s minus 3 power 1 plus c over s minus 3 power 2. Okay, and then you compare the numerator at both hand side. But how to write the right hand side formula expression? So a, you have the s plus 2, you left out this term. So a multiplied with s minus 3 squared. Okay, for b, you have s minus 3 power 1. So you still left s minus 3 power 1. Okay, we don't have the s plus 2. So b times s plus 2 times s minus 3. Okay, c, we have this one already. We left s plus 2. That's why c multiplied with s plus 2. Okay, and then you can substitute s equal to 3. So a term gone, b term gone, you can calculate for the c. Substitute s equal negative 2, the b term gone, then we have the term in term of b term gone, because s equal to negative 2, this term gone, you can calculate for your a. Okay. Lastly, you compare the highest degree term, s squared. So So left side is 1, right side as squared, and then this is bs squared, so a plus b. Compare the coefficient of the highest degree term. Okay, and then for quadratic factor, so a over s plus 1, so b, okay, this is s squared, so remember, okay, numerator is always 1 degree lesser, so this must be s plus c. Okay, and compare the numerator term, left side, right side, so a, using cross multiplication, a times s squared plus 4, okay, and then don't forget, okay, this is a, put the bracket, bs plus c times s plus 1, okay, and first of all, you can compare, okay, the linear term s plus 1 by letting s equal to negative 1. So because s equal negative 1, this term gone, then you can calculate for a term. Okay, you can calculate for the a term. Lastly, okay, because you have only one linear term, lastly, you may next you may let s equal 0. This is 0, so you have 4a. Okay, this one 0, this one 0, you have c. So you have 4a plus c. Okay, s0, so left side 6. Then easily you can calculate, okay, by plug in the a value that you obtain, you can calculate for c. And lastly, again, so you compare the highest degree term. Highest degree term. Okay, compare the highest degree term. Left side, the coefficient is s squared is 4. Right side, you have here a s squared, so the coefficient is a. Okay, this one bs times s, so bs squared is b. Okay, plug in the a value, then you can calculate for b. Okay, if you have the repeated quadratic term, then you plus ABC, so d s plus e over s squared plus 4 squared. Okay, so you may try it, okay, if you have a repeated quadratic term. Okay, so with this, okay, thank you for attention and watching this video.